Hello everyone. Hi, this is our very first video. Okay, so we are going to do all the lectures in online. So just this is our new environment and there's a new way to study. But I think it will be done well. Okay, so lecture 18, graphs of basic functions. So what are we going to do over here is graphs of basic functions. So when you talk about graphs, yes, first we can talk about continuity. Well, continuity means simply the graph is moving smoothly without skipping any point. Okay? So here we go. Example 1. Determining intervals of continuity. Describe the intervals of continuity for each function. Well, the first function graph looks like this. Yeah, look at very closely. Over here is blank. Okay? So here is 0, 2. So when you see this function, the graph is continuous, and then all the way over here, and then it's going to skip this point and then move on to the next point, correct? So we can say this function is continuous on this interval from negative infinity to 0. And then, yeah, 0 is the only point which shows it shows discontinuity. So from here is from 0 to infinity, and over this interval and this interval, so we unite them. So we use union. Okay? On the other hand, the next graph looks like a W over here, and yes. Do you see any point like a hole here? There is no hole in the graph or no gap in the graph. And then this is a continuous over all real number lines. So entire real number line, therefore from negative infinity to positive infinity. Okay? So it is very obvious when you have a graph. Just look for any gaps or holes in the graph. The next one is rather a lot more difficult than just continuity problem over here. Well, even and odd functions. See, even function is well, it sounds a little bit strange, but this way. Even function means f of x and f of negative x. What is f of negative x? Is x is replaced by negative x. Well, even if you replace it, there is going to be the same. Okay? So if this is true, then we call this function f is an even function. Can you think of anything that you can switch this variable x to negative x, still the same? Well, the easiest example would be f of x equals like x squared. You see? F of negative x. Now, negative x replaces x, and therefore it becomes negative x of squared. Okay. When you do that, negative x times negative x, which is positive x squared. So it didn't change. It stays the same. Alright, this concept of function that is called an even function. Well, another function is like absolute value of x. So g of negative x and negative x replaces x, still is going to be same absolute value of x. Well, this is an even function. Well, when you have a graph, What kind of properties does even function have? Well, let's plot a couple of points. So 1, when x equals 1, y is also 1. So 1, 1. When x equals 2, y equals 4. 1, 2, 3, 4. Like this. So this is not a straight line when x equals 0, y equals also 0. So going up like this. What about the other side? Same thing. When x equals -1, -1 squared is positive 1. Therefore, it's going to be same point over here. And when x equals -2, -2 squared is again positive 4. So when you have this, you have a graph looks like that. So what do you see? You see a symmetry about the y-axis. And this is not just f of x equals x squared function. It's going to happen whenever the function is an even function. Okay, it's a very, very important fact over here. Whenever your function is even, the graph is symmetric about the y-axis. Okay? And the absolute value of x, we are going to see shortly, but the graph is like this. Again, it's like a butterfly. Okay? Sometimes I refer to this even function as a butterfly function because the graph is symmetric about the y-axis. Okay. Well, let me check if you really understood. Let me give you a graph. Graph looks like this. Is this a graph of an even function? Okay, let's call this one h of x. Is this function h of x even? Answer is no. Because we see a symmetry, but the symmetry has to be over this x-axis. Obviously, this dotted line is a line of symmetry. However, this is not the y-axis. Okay, so this is not an even function. Okay, so make sure that the symmetry has to be about the y-axis. And the next one is a concept of an odd function. It sounds like even numbers and odd numbers, right? Okay? Well, some concept that we can relate to. Well, odd function is if the function f of x and f of negative x, if they are they are just equal, outright equal, then we call it even function, right? But this time they are not exactly equal, but this is the same as like this. Negative over f of x is the same as f of negative x. Well, is there any such function like that? Well, let's think about it. F of x equals 4x. What about that? Let's change to f of negative x. F of negative x is 4 times negative x. Therefore, this is negative 4x. So they are not equal. However, if you give a negative sign over here, negative 4x, and therefore this and this, they are equal. Correct? So there is a function, looks like this, just 4x. No plus 1, no minus 1, just 4x. 7x, 12x doesn't matter. Okay? Yes, that is an odd function. Well, let's make another example. Is like x cubed. G of x equals x cubed. What about g of negative x? G of negative x is negative x cubed. That is negative x cubed. isn't it? Okay? This is negative x cubed. Therefore, if you give negative sign over here, negative x cubed, they are equal. So one thing is pretty interesting over here. When you have f of x, the power of x is 1. When you have x cubed, the power of x is 3. They are all odd numbers. Isn't that true? Okay? Yes. So I can summarize this. Odd function is like, well, when you have a polynomial function, all the powers of x are odd numbers. So for example, I'm going to set up this one as 2 times x to the 5th minus x cubed plus 8x. If you write this way, yes, all the powers of x is 5 and 3, and what about over here? Yes, this is power 1, so this 1 and 3 and 5, they are all odd powers. In that case, we can call this function odd. Okay? There is no mix. Alright, so k of x is 6x to the 3rd minus x squared plus x. In this case, what do you see? The powers are 3 and 2 and 1. Oh, 3 and 1 are odd, but 2 is an even number. Therefore, when you have these odd powers and even powers are mixed, okay? In that case, we cannot say this is odd or even. So there is such thing as we say, hey, it's neither, meaning neither odd nor even function. All right. Then let's look at in terms of graph, what kind of properties we can see. When you have y equals 4x, everybody knows the graph. Slope is 4 and the y-intercept is 0. So here is 0, 0, and here is 1, 4. Excuse me. Here is 1, 4. When x equals negative 1, it goes to negative 1, comma, negative 4. So we connect these 2 points. And this is a graph. And what kind of symmetry do you see this time? Well, it's quite different kind of symmetry. In this case, this point is going around, coming over here, and coming to the exact opposite position. You see, 1 becomes negative 1, and 4 becomes negative 4. Well, we say this is a symmetric about the origin. Okay, so what kind of change or movement in this graph over here is, if you see A and B on the graph, that means A and B will move to negative A, comma, negative B on the graph, like over here, 1, comma, 4. This one moves to negative 1, comma, negative 4. Okay? So, in example 2, we are going to classify which is an even function, which is an odd function. Yes, the third category is neither. Alright? So there are 3 functions over here. Example 2. A is g of x equals x to the 5th plus 2x cubed minus 3x. When you have a polynomial function, really, just look at the power. Those powers are, well, here is 5, here is 3, here is 1, So 5 and 3 and 1, they are all odd powers. Okay? In that case, we call this function odd function. What about part B? B, h of x equals 2x squared minus 3. In this case, what is that? All the powers are 2 and, what do you think over here? 2. And when you have just constant 3, you can think this one is 3 times x to the 0 power. You know what I mean? So whenever you have a constant term, you can change this one to 3 times x to the 0. So what kind of powers do they have? It's all even numbers over here. In this case, we call this function even function. Yeah, part C. K of x equals x squared plus 6x plus 9. Okay. Well, I see some kind of mixture over here. I see immediately, here is power 2. Here is power 1. It's already mixed, correct? In that case, we are going to say neither. It has to be one way or another. It's all odd powers or all even powers. Is mixed powers of odd and even. In that case, we must call it neither. Okay? Well, in terms of symmetry, well, I already talked about that. So, let's read this. Symmetry, the graph of an equation is symmetric with respect to the y-axis. Okay? So, if you have over here 1, 3, when you change it to -1, still 3, positive 3, when they are equal. Okay? In that case, this is a graph of an even function. And odd function case is, I'm going to use the same point. So same point over here, 1, 3. So this time it will go to -1, -3. The both x and y, they are opposite. Okay? That one will give you the graph of an odd function. Example 5. Testing for symmetry with respect to an axis. Okay. A. X equals the absolute value of y. Well, what kind of graph is this? X equals the absolute value of y. So let's choose x and y. Let's choose y equals 0. Of course, x equals 0. If y equals 1, x equals 1. If y equals -1 and y is still positive 1. Let's do 2 more. If y is 2, x is 2. If y is -2, x equals same 2. So can you see the graph? What kind of graph do you see? Over here, 0, 0, 1, 1, 1, -1, 2, 2, 2, -2. the graph is going this way and this way. Well, so this is a graph. So what kind of symmetry do you see? Yeah, the symmetry is about the x-axis. Well, can you call this as a graph of a function? Maybe not. Okay, you cannot call this a graph of a function because it does not pass the vertical line test. So it's not a graph of a function at any rate, but there is a symmetry. Symmetry is about the x-axis. And the next one is y equals here b. Y equals absolute value of x minus 3. Y equals absolute value of x minus 3. So let's make a chart again. X and y. This time you can choose from x, okay? Not a problem. When x equals 0, absolute value of 0 is still 0, so 0 minus 3 is negative 3. When x equals 1, negative 2. What about x equals negative 1? Negative 1 still gives you positive 1, that gives you negative 2. When x equals, let's move to 3. When x equals 3, y equals 0. When x equals negative 3, again, y equals 0. See what kind of graph we see. When x equals 0, negative 3. Negative 1, 2, negative 3. When x equals 1, y equals negative 2. When x equals 3, the 0. 1, 2, 3. Yes. The next one, when x equals negative 1, negative 2. When x equals negative 1, again negative 2 over here, as before. When x equals negative 3, y equals 0. Yes, negative x equals negative 3. Positive 3, y is 0. When x equals negative 3, again y equals 0. So once you connect these dots, we are going to have a graph, looks like a V again, okay? Yes, you remember earlier, y equals absolute value of x. The graph looks like this. When x equals 0, y equals 0. When x equals 1, y equals 1, so on and so forth. So here is 0, 0 is on the graph. On the other hand, over here, the tip of the graph is 0, comma, negative 3. Okay? So what kind of symmetry is that? Yes, this is a symmetry over this y-axis. Part C,